Assalamualaikum and very good day to our lecturers and fellow friends. My name is Amin Shafiq bin Ash'ari. My latest number is CF220062. Today I will explain about introduction. First, beam are vital structural element that support and transfer load in construction. Their behavior, particularly deflection, is the crucial in the structural engineering. A comprehensive background study encompasses beam mechanics, fundamental and method for estimating and managing deflection. And for our popular statement is most the accident that happen at concrete beam are from deflection. Here some example are a poorly designed concrete beam may experience excessive deflection beyond safety limits, leading to structural instability and potential failure. And number two is mistake during the construction phase, such as incorrect installation of reinforcing element or poor concrete pouring practice may contribute to deflection related accident. So, to mitigate the beam deflection, we use up bisection method should be applied to the concrete beam to solve nonlinear equation or find roots of continuous function, which is different from the typical analysis and design consideration associated with being in structural engineering.
Objective: to understand the behavior of structures, especially under varying load, to reduce the error to close enough to zero value, to identify an approximate method to be used.
Method recognized as a popular numerical technique for locating roots of non-linear equation. This method involves systematically reducing an initially specified interval containing the root suitable for solving nonlinear equation with precision. For the methodology of this method, firstly need to define the function and choose an interval. Secondly, check the sign change and calculate the midpoint. Third, evaluate the function C and update the interval. For the next step, repeat the process with a new interval and continue the iteration until the interval becomes sufficiently small or function close enough to zero.
Okay, so let me explain more about the calculation, which is, as you can see in the slide, it was the deflection, the vertical deflection of the beam is given by 0.452 exponent negative 4 x power of 3 and etc., where x is positioning along the length of the beam. Hence, to find the maximum deflection, we need to find where if the fx is equal to 0 and conduct the second derivative test. The equation that give the position where the deflection is maximum is given by negative 0.595 exponent negative 8 power of x power of 6 and etc. So we are using the bisection method to conduct the iteration to estimate the root of the above equation. So we need to find the absolute relative approximate error at the end of each iteration and the number of significant digit at least correct at the end of each iteration. So as you can see in the slide beside, it was the solution that we need to calculate to insert it on the table. So we assume that xi is equal to 0 and xu is equal to 35 because of this situation. So that we just substitute all the value in the equation so that we got the fxi is 0.018 and fxu is equal to 0.1061. So the step is all actually being repeated until we go to the next slide. Okay, so this is the continuous calculation based on the slide before, which is where we get the 17.5 is we get the calculation from the first iteration that we calculate. So xi is equal to 17.5 and xu is equal to 35. So we calculate as usual for the second iteration and the third iteration. And don't forget to calculate the iteration percentage, which is x new minus with x old divided by x new times with 10. So we get the percentage of iteration. So now, none of the significant digit are at least correct in estimate area, which is xn is equal to 26.25. Okay, so we are going to the next slide, which is the table that we are substituting all the values that we calculate.
7 more iterations were conducted, and these iterations are shown in table 1. As you can see, at the end of 15th iteration, we got the value is 0.02%, which is 0.0002. Hence, the number of significant digits are least correct is given by the largest value of for which 0.0002 is less than 0.5, which is 0.0005. So after we do the calculation, we get the answer, which is M is 2. The number of significant digits at least correct in the estimate root 17.509 is 2.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal bin Muhammad Nazri. My matric card number is CF 220084. I will explain about the discussion from our project. So from the result obtained using a bisection method in finding the maximum vertical deflection of the concrete beam, this is the most suitable method in solving our problem. By using the bisection method of finding roots of the equation to find the position of x, where x is the position along the length of the beam, student can find the absolute relative approximate error and at the end of each iteration and the number of significant digits at least correct at the end of each iteration. So 15 iterations have been conducted to estimate the roots from the given equation in the project. So at the end of the 15 iteration, the absolute relative approximate error that student obtained is 0.02%, which is below and comply with our needed requirements, absolute relative approximate error below 5%. So we are moving on to the conclusions. As a conclusion, the main objective of our works is to determine the behavior structures, especially under varying load and conditions value. In order to solve this numerical problem, bisection method had been chosen to find the absolute error between exist equation and the maximum deflection equation for the beam. Consequently, from the methods examined in our calculation, we are capable of showing numerical integration for finding the absolute error from the equation by using method of bisection that we have discussed. That's all from me. Thank you.
Okay, jadi untuk starting ni projek numerical,
Ya, saya.
dia tentang application of numerical mathematics. Pasti dia ada cakap sekali kat sini, tak kisah pasal subtopik apa, pasal chapter apa pun. Yang penting menggunakan numerical punya method
Dalam engineering.
dalam engineering. Maksudnya the problem created could be solved using numerical method, which is learned in numerical method. Numerical mathematics lah. Lepas tu dia suruh add on sekali fill table gitu. Tu macam biasa, report, intro, table of content, question, reference. Cuma topik kita sekarang, kita nak kena buat soalan.
Tanya topik mana?
Tanya topik mana dengannya kita
Engineering
nak
problem.
settlekan problem ni. Dia ada bagi tahu sekali structural, hydraulic, environment dengan geotech. Ada 4 scope
Structure.
structure. Sama
Structure lah paling common kan? Semua
Kita
dalam.
besar.
geotech bisa sikit.
Kalau macam yang kena apa, kita mau bagi example. Structure. Structure, kita
B.
Beam. Beam column semua tu lah. Mana nak ambil? Beam tu column?
B.
Beam lah.
Dia try beam. Beam aku rasa sebelum pernah nampak. Dia ada cakap pasal dia buat kerangka kajian pasal bookshelf.
Pakai method?
Maksudnya yang
Yang ni dia pakai bisection ke?
rak buku tu komplit. Bukan komplit beam kan. Lepas tu ada kajian pasal rak buku, bookshelf.
Tapi dia pasal kayu lah. Jadinya macam bookshelf ni dia nak kira maximum deflection dekat dia bookshelf.
Oh.
Bookshelf tu biasa, macam rak buku biasa.
Cuma kita gantikan dia macam beam lah.
Kita macam aplikasikan
Application
dia.
kan. Dia kan sama je.
Tapi dalam takkan kita nak kira. Ini yang dia bulat. So kita tukar. Masa kita tukar, dia pun okey juga.
Kita cari deflection.
Yes, kita
Jadi material kita
Material berbeza.
Green.
Ya.
3, 4. Okay, dah.
Skala.
Sekarang ni aku baru siap calculation pasal bisection lah. Sebab korang nak bisection kan masa tu. Ni aku dah transfer based on equation yang aku dah buat sendiri dengan equation yang already exist dekat je bin tu lah. So macam ni exist dekat je bin tu. This one yang kita created sendiri untuk nak compare. Sebab bisection kan dia nak cari absolute error kan. So kita compare daripada dua ni, which is banyak tak dia punya iteration dia lah. So aku dapat kat sini 15. So untuk calculation ni je lah. Tapi cuma aku perlukan korang untuk isikan format supaya betul lah. Dia punya calculation sudah complete dah.
Aku dah cari sikit tu literature review.
Apa ya? Okay, tinggal nak masukkan je ni. Tinggal compare. Lepas tu terus compile.
Mana tinggal apa lagi?
Itu tinggal WhatsApp.
Tak, 4 lain. Item apa tu? Discussion.
Untuk report.
Record.
Discussion dah siap, boleh start buat discussion.
Intro apa?
Introduction. Ni. Bukan. Ni yang saya boleh.
So dah settle ni?
Dah. 15 saya saya.
Calculation pun dah settle. Lagi ni literature review.
Hari ni boleh siap.
Siap.
Native.
Objective, discussion, conclusion.
Okay, conclusion.
Tu tak table.
Sudah table.
Tu boleh siap semua hari ni. Boleh siap hari ni.
Ni boleh siap kan?
Lepas tu kita boleh start untuk slide dengan video.
Slide siapa nak buat?
Semua.
Semua buat apa macam ni?
Presentation? Presentation?
Semua juga.
Semua orang. Semua empat macam ni.
Slide yang kau buat, kau buat video tu.
Kita buat nama Canva.
Ya.
Tinggal tu je lah.
Siap hari ni.